Welcome back to Smart Architectural Programming. Whether you're diving into Java for the first time or brushing up on your skills, you're in the right place. Today's topic, a powerful concept in Java that would help keep your code clean, flexible, and intuitive: method overloading. So, if you're following along on our YouTube channel, this is one of the next videos on Introduction to Java playlist. And if you're following along as an accompanying video to our Introduction to Java book, you are in the right place, and we're focusing on a very, very important topic related to how to leverage arrays in Java basically, and that is method overloading. So now that we understand that, next thing we need to understand is basically what is method overloading. That's the next important aspect that we need to understand if we want to move forward. Generally speaking, method overloading in Java means creating multiple methods in the same class, all with the same name but different parameter lists. So if you focus on the three important points on understanding method overloading, is that it's the same method name. So we have multiple methods with the same name, which is functions basically. If you're more familiar with other programming languages, the methods are called functions there. Number two, they have different number of parameter types, so that's the distinction between these methods with the same name, and they happen within the same class basically. Java basically determines which method to call based on the number and type of arguments you pass. This decision is made at the compile time. This is what we call compile time polymorphism. So I'm not going to go deep into compile time polymorphism, but what you need to understand is we have a method overloading is basically methods with the same name, different parameters, and Java basically determines which they're also within the same class, and Java basically determines at compile time which method to use based on the amount of parameters being used at call time basically. So now that we understand that, we need to understand method overloading further, and to do that we need to understand method signatures, right? So a method signature is basically includes a method name and the parameter list. That's it. It does not include the return type or access modifiers. So a method signature, which is its identifying mark, is its name and parameter list. So return type does not affect method signature, so that is not included in the method signature. This means basically you can't overload a method just by changing the return type. So that is an important distinction to understand. So basically you need to understand that we can't overload a method just by changing a return type. So if you look at the screen right now, we have a code here, right? So we have pretty much two codes here, and what we're trying to do is use method overloading. We have the calculate name here and parameter, which is int a, right? Similarly, we have calculate name here and a parameter int a. Now there's no difference here between calculate name, the parameter names, and the parameter the method names and the method parameters here. And that is problematic because we need one of at least the name to be different, or in case of method overloading we need the parameters to be different, right? But that's not the case because unfortunately, let me use a different color here just to mark this down. Unfortunately, here you notice that we have tried to use the return type as a differentiation point, which is wrong. That does not differentiate because it is not a method signature at that point. So this problem makes sure that we can't overload a method based on return type, right? That's a return type method. That's the object that this method should return when the entire method has been run or called, right? So that is the important distinction you need to understand when we're talking about method signatures. Method signatures are the key features based on which we can do overloading. And other than that, if you try to use any other aspect to do overloading, that won't work. So based on that understanding, let's look into how to overload a method effectively, right? Now we understand what method overloading is, what method signatures are. We need to understand how overloading actually works. So how you can use that effectively. So the three things you need to remember to make sure method overloading is consistent. Number one, you need to keep behavior consistent, because overloading methods should perform similar actions, and you wouldn't be sure exactly what would with the same names exactly how to leverage what if they have different functionalities. So always keep the ultimate behavior of the methods which are in part of method overloading the same. Basically, they should perform similar actions, only their inputs should be different. Number two, you need to understand, you need to improve readability. That is, don't just overload for fun, use it when it makes the code easier to understand. That is the core aspect to this that you need to understand here. That it's not used to just have fun or just to learn a neat trick in coding. What's important here is basically to improve readability. So if you need, if you have a certain process, let's say addition, right? From a calculator example here. You can do addition with 2 integers, 3 integers, 4 integers, 5 integers. Let's say that there are only 5 integers that you need to do addition with, right? And in those circumstances, what's important here is that we can use method overloading, because the process is the same, the end goal is the same, but the difference is we have different addition parameters, right? We sometimes we'll have 2 values that we need to add together, sometimes 3, sometimes 4, sometimes 5, right? And in that case, readability is improved if we don't have functions add 1, add 2, add 3, add 4, add 5. That makes it cumbersome and annoying. But instead we have, because in some cases when you're leveraging the function or using it, let's say further down the line you use it in code to add, let's say, add something, and let me just say that you need to add, let's just you need to add 3 digits together, right? And then you need to add 2 digits together, and then you need to add 5 digits together in some place in the code. It would be very, very weird for a third party to understand add 1, add 2, add 3, add 4, add 5, right? He would be thinking, what does this mean? Add 3 first, then add 2, then add 5. That's kind of weird, and it makes reading a little bit difficult. So to avoid that, we use method overloading, where we basically use the same word. Even if we're adding 3, we use add. Even if we are adding 2, we use add. Even if you're adding 5, we use add. But the difference is all of these add functions have different parameters, and that's where method overloading becomes useful, because now we're adding different amounts of values at the same time and using different methods with the same name, just with different parameters. So that is another reason, aspect to why and when you should use method overloading effectively, helping your code readability. Number 3, you need to understand descriptive parameter types. Don't overload methods that confuse the reader due to similar types or unclear intent. So let me put it this way. You need to be if there's a certain procedure that you can be very, very descriptively clear about, do that. Don't use overloading there. Be clear about that procedure. In case of add 2, 3, 2, 5, it isn't very clear in the method name for us, so we can use overloading. At the same time, if there's a specific aspect to it, let me put it this way. So addition is not addition. Let me think about the exact analogy that I might give you here. So let's say, let's leave the addition subtraction behind. Let's say you need to manage traffic, right, at a junction, right? And there are 2 junctions, and in one junction you use a certain amount of code or method to solve that traffic controls basically on when to go green and when to go red, right, for each of the the roads connecting to that junction. Similarly, you might need to do that for another street, but the difference is the traffic volume, the traffic conditions, the amount of connections to that junction, all are different. So you can be more specific in saying junction at this place and junction at that place, right? You can be clear exactly on what junction it is. So you don't need method overloading there. You need specific descriptive names to identify each procedure, which might be similar in the code, but it might have different ways it's handling the volume or different aspects to it. So you can be descriptive about it and people can read that and it's readable, right? So it does away with the issue of readability there basically. So now that I think we have clearly understand what method overloading is, what method signatures are, and how you can when to use them effectively, right? Where to use them and when to use them, right? Effectively. Now let's look at some practical code examples to push this ahead further. So some practical code examples is this one here, right? Here's a simple overloaded method example, right? Say we want to method to greet users in different ways. So we have a greeter class. Within that greeter class, you'll notice we have one greet function. This is the first one, the first greet function, which has system.print and just says hello, right? Then we have the greet number function number 2, which basically says, this is not correctly. So this is greeter function number 2, which basically writes hello, then the name of the person, hello, then the name of the person, and then an exclamation mark, right? So it's different than the greet number function, which just says hello. And the third greet function here, which is right here, and let me write 3 over here. You'll notice here we have hello along with the name. Then we write a period and say you are this age, years old. So here we're not just saying hello, we're saying hello and telling you the age of the person, right? So there's the 3 different user returns or applications of this function, right? All these methods are named greet, but their parameters are different. Java knows which one to call based on how many arguments you pass to the or how many parameters that you add when you're calling the function, right? So if we say we set up the new class greeter here, right? And then we say then the first one we just pass with no arguments. The first function here has no arguments, so Java automatically compile time understand this is the function, the greet method, which it has no parameters, and here no arguments are called, so that this means we need to use the first one, and it says just hello, right? Then the second one, it has one parameter. Java realizes, hey, this one has one argument when we're calling the function, and there's a function that requires that has one parameter, so it knows which at compile time to call the second greet function, which is that's why it's hello. It writes hello Sam, and then we have the third greet function here. Java realizes that it has 2 arguments in it, and which means it needs to go to function number 3, which has which requires 2 arguments. Which has 2 parameters required, right? This means it's going to use the third greet function and say, hello Lena, you are 25 years old. So you can understand that as a dynamic ability of Java to identify functions using method signature differences. Either the name could be different or either the parameters could be different, right? So that is basically how it works, and basically understanding this concept by going over some practical code, right? So let's look at some real world use cases for this as well. So now imagine you're building a public library system, right? You want to might want to add books using a specific add book method, right? And you see we have 3 add book methods here. We have one add book method that just does with title, which is our first add book method. Then we have the second add book method, which requires a title and an author name, which is our second add book method. And then we have a method that requires title, author name, and year it was published, right? So these are 3 add book methods that we have when we're trying to build a library system, right? This gives users of your class flexibility while keeping the method names meaningful and consistent. It gives the opportunity for someone to add a book that has only the title name available, a book with a title name and an author, a book with a title, author, and year it was published. So this is one of the use cases that might be be used when we want to use Java method overloading, right? So let's wrap it up, right? And a quick recap and key takeaways from this video. Understanding method overloading allows methods with the same name but different parameters. Java uses method signatures to determine which method to invoke, and use overloading to improve flexibility and readability, not to confuse or not to just use for the sake of using. So if you found this video helpful, don't forget to hit that like button and subscribe to Smart Architectural Programming for more Java insights and programming principles. And if you're reading along with our Introduction to Java book, this is just one of the many practical tools you'll master. See you in the next video. Code smart and live even smarter.